I would like to welcome you all to this our first webinar. Good afternoon, actually, to all of you in Australia and Asia, and good morning to I think Sandra and others from Europe. I would like to welcome you all to this webinar. I'd like to begin by acknowledging the traditional custodians of the land on which we meet today, the Whadjuk Noongar people. I pay my respects to elders past and present, and I extend that respect to all Aboriginal and Torres Strait Islander peoples joining us. Their deep knowledge, custodianship of country, and long history of innovation continue to guide how we think about land, resources, and stewardship. I thought that first I probably would like to start with a quick introduction on Mirawa and why are we doing this, and then hand it over to our first speaker, Dr. Sandra Pavón. Mineral Research Institute of WA is a statutory organization established by the WA government. Our work focuses on addressing key knowledge and technology needs of the state mineral sector, aligned with priorities set out in the Mirawa Research Priority Plan. So through financial assistance for research projects and scholarships, we drive high impact applied minerals research that strengthens the global competitiveness of Western Australia minerals industry. This initiative, the series of webinars, we wanted to have speakers from well-known research organizations that we've done a lot of work in the critical mineral field and in the tailings valorization. We picked 5 organizations from Europe. The first one is Fraunhofer from Germany, and the second one is going to be in another month time, CEA, the French Atomic Energy Agency. The third one is going to be Sintef from Norway. Fourth one is BRGM from France, and the fifth one, VTT from Finland. So our aim is really to encourage discussions, to see what others are doing in this field, and see how we can benefit from knowledge sharing and perhaps fostering collaboration. So our first speaker is Dr. Sandra Pavón from Fraunhofer Institute. And she'll be talking to us. The title of her talk is Towards Sustainable Critical Raw Material Production, Lithium Recovery from Spodumene as a Demonstration Case. Sandra is the manager of the research group on hydrometallurgical recycling and raw materials chemistry at Fraunhofer IKTS in Germany. She has over 10 years of professional experience in the development of technologies and integrated processes for the recovery of metals from both primary and secondary resources. Sandra began her academic career at Polytechnic University of Catalonia, where she obtained a degree in chemical engineering and later completed a PhD in chemical process development. During her studies, she gained valuable industrial experience working at Roca Sanitario, as well as a startup affiliated with Telefonica. Since joining Fraunhofer IKTS in 2022, she has played a key role in advancing research on sustainable recycling technologies. Dr. Pavón has authored more than 40 publications in renowned scientific journals and is a frequent speaker at international conferences where she contributes to discussions on circular economy, sustainability, and innovative materials recovery solutions. So as I mentioned, Sandra leads the research, critical minerals research at Fraunhofer, and it's noteworthy to mention that Fraunhofer already has got a collaboration program with ECU through Ideas to Industry Lab, which was developed in partnership between Fraunhofer and ECU. Really good to have this program in place. So infrastructure for doing more research, more collaboration is already there. And I would like Sandra to take it from here and to talk about what you guys have done in Germany, and then perhaps also touch on your partnership with ECU. Over to you, Sandra.
Thank you so much, Selwyn. So good morning and also evening to all the audience. And like Selwyn already said, I'm Sandra. I'm the group manager in Fraunhofer IKTS. And I would like to give a short presentation about not only what we are doing and what are our expertise, but also how we are working with, not only from academia, especially from the industry point of view, and the first great collaboration that is already settled with the SEU, and this is why I'm here. So thank you, Salwan, to get me in touch through Steve Elias, and that I'm able to do the first speech in this webinar series. I will now to share my presentation, and then I will start, okay? I hope you can see my presentation, and I can go to the presentation mode.
Oh,
yeah?
All good. All good.
Perfect. So I will start. So like I already said, I would like first to say that I'm working in a big applied research center that is called Fraunhofer. Obviously, if it's applied research center means that we are going through the complete value chain and solving real problems from the industry. Fraunhofer is around the world, especially obviously in Germany. You can see in the map all the sites that we have and all the institutes. We are 75 institutes within this Fraunhofer society, more than 30,000 employees around the world, and I'm belonging to the one that is in the right side, that is in Dresden, the headquarters that is called Fraunhofer IKTS. What we are doing in IKTS, the focus lies in developing ceramic materials, obviously the name ceramic technologies and systems. We are not only focusing on the material development, we are implementing this material development in the different value chains, in production and also in recycling. We are a little bit more than 830 employees, and only from the Fraunhofer IKTS, we also have 13 sites. I'm belonging to one that is the headquarters, but all the pilot plants that we have in recycling is close by. I will give you an overview a little bit later. So how we are collaborating within all the academia as well as the industry is we are establishing collaboration and complementary synergies. We are doing that since Fraunhofer started because especially in Germany, the academia is really strong. So we are developing first the fundamental. Usually, this is the focus lies in the different universities, and then we are applying and validating the different ideas in the Applied Research Center, so in Fraunhofer, and then we are reaching more the gap between university and industry in order to provide not only the solution, but also all the IP related. So that means that this duality and complementary synergies is really our daily basis, and that is why we think that this can be also a good start in Australia from our side. So especially in Germany and where I'm working in Fraunhofer IKTS in Dresden, we have really a strong collaboration with two different universities. One of them is the university in Dresden. In fact, the head of our institute in Fraunhofer IKTS is also professor there. That is why the collaboration is really strong. And also from a recycling point of view and where I'm placed, all the recycling pilot plants, is really strong in Freiberg, is the oldest mining university. And also we have different collaborations and synergies there for developing the complete value chain. So that means that we are trying to tackle all the challenges from material development until production, including the recycling, to fulfill all the circularity and challenge from the energy transition. So that means that for 10, 15 years, this is already established, this triangle, I would say. But what is happening now since almost 1 year, 1 year and a half, is now we are not triangle anymore. Someone appears here, and this is the ECU. This is the real collaboration with the joining lab and industrial lab. So it's already established a collaboration between the ECU and Fraunhofer IKTS. And that is why we are trying to be more present in Australia to understand how the market is, and trying to provide and establish the same that we already have here in Germany, but also synergies and partnerships. How we are developing from the scratch until industrial implementation. We are starting from the idea base. So we are trying to develop alliance. So usually the company is coming to us and telling what is the challenge. Can be different ones, so from technology point of view until how to adapt the already process and the value chain that they already have, but with new input material. So how to adapt the current processes and technologies that they already have in their facilities with the new input material that we want to test. So when then we are establishing R&D projects, and obviously we are providing all the guidance through the entire value chain. We are establishing this partnership, and once this idea is already validated in laboratory scale, then we are going through the next phase. So prototyping the solution in pilot plant, obviously including the techno-economical balancing. Without techno-economical balancing, the industry is gone. So that means that we have to implement that from the beginning. And once this is already validated and we have clearly green numbers, then is when we are going through the next steps and the final steps with full implementation. With the full implementation means that is including all the all things related to the IP licensing, OIP development together. This is establishing from the beginning all the regulations and how we want to collaborate. We are open for everything. And obviously the transfer to full pilot scale in the facilities of the industry. Usually the implementation is in the facilities of our client. So that means that we have obviously to do this transferability. So we are going there to settle all the implementation. And once the transfer, not only from a pragmatic and technology point of view, but also from the knowledge point of view, is already settled, then we can think about finishing the collaboration or still doing time to time some refining and fine tuning for this pilot plan or this solution or this technology. This is something that we already have established with partnerships around the world. This is not only from Germany. So that means that is something that is not new for us, and we can do it quite fast, I would say. So I would like now to start telling you what we have from a raw materials and recycling point of view, from primary and also secondary sources. So we believe, and our idea and our strategy is trying to develop holistic approaches. What I mean with holistic approaches is that regardless the input material that we have, we are trying to develop the complete value chain. We believe that technologies should be flexible, because the raw materials that we have today won't be the same in 3 or 4 years, especially from secondary sources point of view. So obviously all the production and all the technology from production side is developing and is evolving through time, and that means that our recycling facilities has to be from the starting point ready to tackle the challenge and the solutions from tomorrow. So that means that we are developing different technologies and circularity concepts, taking into account the planetary boundaries. So all the regulations, especially for us, usually is Europe, but this is not only the main regulation and jurisdiction that we have in mind. And when we are developing everything, we are trying to automatize as much as possible. So we are trying to develop all the metrology, sensing, and digitalization from the beginning in order to have full control of the full pilot plant in the facilities of the clients. That means that we are tackling primary sources and also secondary sources from end of life product, as well as production waste. The sustainability and cross-solution from water, energy, and food security is a mantra for us. And in order to implementation in the industry and try to tackle all the cost efficiency recycling processes, we have mainly 4 research areas. One of them is closing the loop. So all the waste that is produced through the process, we are trying to do 2 different approaches. One of them is trying to recirculate this within the same process, or we are trying to make in a way this waste that is transformed to resource for another industry. So we are selling this waste product that for us is not waste because it's already a resource. The second one is smart processes. Like I already said before, we are trying to include all digital monitoring to optimize the processes and the material recovery. So from the beginning, we are trying to establish the digitalization from the start. Then usually when clients are coming to us, they already have something in their facilities. So obviously make no sense start from the scratch. Make no sense start from the beginning and do everything new. So we are trying to adapt the already available technologies, facilities, pilot plans that they have in order to reduce as much as possible the complexity and obviously the cost efficiency to try to increase the cost efficiency. And now this is a new concept, I would say, from 3, 4, 5 years maximum, that is this safe by design or sustainability by design. That means that when production, new material development is starting, we as a recycles developers, we are trying to think about which challenge could have this material from the recycling point of view. So that means that when everything is starting new in a production, we are trying to think about how would this affect in the current recycling value chains. Where I'm working, this is in this slide, in the right side on the top, you can see 3 main sites from Fraunhofer IKTS that are developing different areas from recycling. The main, so the headquarters is placed in Dresden, and the main areas that they are working with is the process wastewater treatment. I'm placed in Freiberg in the Technology Application Center, and this is mainly focused on critical raw material recovery, so the development of technology and also processing. And the other site is in Ensdorf that is focused on development of membranes. So we are trying to tackle these 5 areas that you can see in the middle of the slide. So developing the process and the technology, so for recovery of critical raw materials. When we already have products, what we are doing is what we call recyclage evaluation. So that means we are performing a characterization, and if already satisfy and fulfill some applications that we already selling that to our clients. If not, then we are purifying them. So we are trying to reduce as much as possible the impurities depending on the application that we want to sell that. And then afterwards we are selling them. Obviously, we are focusing in hydrometallurgy. So hydrometallurgy means water. Hydrometallurgy means chemicals. So we have in lila and also in yellow really key areas where I would say that we are really good at. We have all the facilities for process water treatment as well as process chemical recovery. And afterwards, we are doing the assessment. We are doing LCAs, we are doing LCC, we are doing TEA, so techno-economical assessment as well. So which technology we have in order that you can see if this can be useful for you and for your challenges. I try to summarize. Obviously, we have more than that, but I try to summarize to not talk 4 hours. One of the main cores for us and the main areas that we have is lithium. We have 2 processes that we can be in a semi-pilot plan. So we have the cool process, the one that I will explain later. That is the use case that I already selected for today. That we have 250 liters autoclave in our facilities, and this process is already patented. So it's patented by the University of Freiberg, and we are the one responsible for the validation from primary as well as secondary sources. So that means that it's a holistic approach. And we have a second one that is a jointly work, so it's a jointly patented process that is called field process, and is patented with together with the University of Freiberg, but IKTS was also involved here. From the metal separation, we have the common technologies, solvent extraction in a batch modus as well as continuous modus, including membrane contactors. It makes sense because we have a site that is developing the ceramic membrane contactors. Then we have ionic exchange, precipitation, complexation, crystallization, and so on. Afterwards, we have the purification and refining. We have different technologies. Some of them are already listed here. Electrodialysis is one of the core technologies for us that we have also pilot plants. Electrowinning to get already metals. Or we have also AOP technologies also for removing organic components. And the last one that I think is important for you, or I already think that could be some questions regarding this topic, is how to valorize the rest when we are talking about primary sources. And we already are working with geopolymers. I will explain you what is these geopolymers afterwards. So from purification and water point of view, we are considering water as a resource and not as a waste. So that means that we are trying to clean this water when it's already processed through the different process that we are developing, and we are trying to reintroduce this water within the same process. We have you can see here some application membrane pilot plan, semi-pilot plan, and we can tackle all the steps in the value chain. So we can develop already the membrane contactors, and until we are setting as well. So we are the responsible for make all the setup from this semi-pilot plan, and also the ones to use them and to validate the process. From the assessment point of view, how we are working is we are trying to monitorize. So that means that we are introducing all the engineering side for monitoring. Then we are modeling and visualization task for evaluating the different scenarios. And when we are evaluating, then we can identify where the process can be optimized. And this is not only once. I want to I want to tell you that this is an iterative process. We cannot only do this once and then that's all, because obviously we are running the process in client facilities with different input materials. So input materials can be similar and is already are similar, but will never be the same input material. And that is why we have to iterate that. So now I would like to go through the use case that I already select, and I focus on lithium. Why I'm selecting lithium? We 3.5 years before start this project, this big European project that is called Metallico. To boost the energy, the green transition, obviously critical raw materials need to be ensured, especially in Europe, where we don't have so much primary access. So that means that we wanted to have a project to be able to recover these battery metals from primary and also secondary sources. Secondary sources meaning tailings. So the objective for us through and within this project is obviously recover these valuable materials from primary and secondary materials. We are demonstrating the sustainability production because we are setting this and at the end of the project in TRL 7. So that means that there are full pilot plants, or I would say for you maybe from the industry, TRL 7 is not the full pilot plant, that for us, yes. So it's a scale thinking. Then obviously we are integrating and enabling social participation and stakeholder engagement. This is really important here because especially in Spain, that the coordinators are placed there. We have different minings, but not all the minings have the green light and all the permissions to be open. So that means that we wanted to engage also the people to understand what mining means and to try to get rid of all the concerns that they have. So something maybe not new from you, the energy transition, the electromobility is one of the cores. And from if we are talking about electromobility, obviously batteries is one of the resources from us, I would say. If we see a really schematic battery in the right side, from the 34 list of critical raw materials from Europe, I think that you can see that all of them, or almost all of them, are in red. So that means all the metals placed except aluminum, but aluminum is also considered a strategic raw material, are critical ones. So critical ones from a supply risk and energy importance. So that means that if we want to continue develop batteries and also recycling them, we have to tackle all these metals, including, for instance, the main or the important ones: lithium, manganese, copper, nickel, cobalt, and graphite. So now I'm going a little bit deeper in this project. From this project, we have 5 different processes for metal recovery from primary and secondary materials. We are 21 partners from 9 different countries. 50% of the consortium is are companies, so that means that we are collaborating with them. Mainly the role from them is from implementation side, so that means that we are developing the process, but they are implementing these processes in their facilities, so that means mining companies, as well as end of user valorization company. So that means that we are producing different products, and then they are testing these products in different applications. So like you can see in the right side, you have different processes. The cool one is the one that I will proceed with the explanation later. It's not because it's cool, that's also, but because it's CO2 leaching based. Then we have a Tailco process that is main focus on cobalt recovery from tailings. Purgers, that is also cobalt. recovery from pyrometallurgical refining processes, then coney, cobalt, nickel, and cobalt, and copper, sorry, this is a mistake in the slide, and then from common is cobalt, copper, and manganese from tailings generated in ore concentration plants. The European contribution, so the funding, is almost 12 millions. I would say that this project is in the last phase, so would be between 6 and 9 months left. So that means that the complete optimization are almost finished. So that means that we can proceed from the implementation in the client side. I don't know why I cannot go through next slide. Okay, that why lithium, the problem that we have with lithium is that if we see from primary sources is really low concentration, and also from secondary sources there are a lot of types of batteries from primary and secondary batteries, and obviously from a secondary point of view we have a lot of concerns from security and safety. The scenario that we have for the next 30 years is that 25% of lithium demand will be covered by secondary lithium. Obviously, it's not all. And from the last years, the focus was mainly placed in cobalt and nickel recovery and not on lithium. So that means that the processes that I already established mainly are pyrometallurgical ones, so that means that lithium remains in the slag and try to recover lithium from a slag. I won't say that is not possible, but it's really challenging from economical point of view. So that means that the consequence that we have is we need recycling of secondary sources as well as also tackling the primary raw materials. And that is why we are trying to develop this holistic approach with technologies that can work regardless the input material that we are working with. Especially in Europe, we also have this challenge from the supply risk because the production and the reserves are outside Europe, mainly placed in Australia, so you already know about it, Chile, Argentina, and China. Now I want to present the cool process is a holistic processing of primary and secondary raw materials. So we can tackle and we can mobilize lithium coming from primary sources, so like spodumene, symbaltite, lepidolite, and pentandite, as well as lithium-based material, so that means from the black mass. The pre-processing obviously is different, so we can not do the pre-processing the same from primary and secondary. So from primary side, we need a thermal activation usually in order to change the phase of, for instance, spodumene from beta spodumene to alpha spodumene in order that is more available the mobilization and the recovery of lithium. From batteries, what we are doing is obviously first is a discharge, then mechanical treatment, crushing, grinding, sorting in order to have the black mass. The black mass is where all the valuable metals are placed, cobalt, nickel, mangan, lithium, and also graphite. And then this is both are merging in a leaching with CO2. We are going to supercritical stage, so more or less 230 to 150 degrees and 100 bars. And then we are able to selectively recover lithium. So that means that in the leachate remains lithium with some silicon from primaries and also aluminum from secondary side. But these both are not problem because we can proceed with the downstream going through silicon removal and then a reverse osmosis in order to do the refining. So not only concentrating, but also making the last separation in order to proceed with the lithium carbonate precipitation. So what we were doing since the last 3 years. We got spodumene from Nigeria. We got lithium content around 3%. And we start with the thermal activation, adding sodium carbonate. And then we could decrease the temperature from 1,100 and 1,100 degrees to 750 through 3 hours. And then we already have alpha spodumene that can be processed directly through our reactor. This is our pilot plan in Freiberg, in our facilities, Fraunhofer facilities, 250 liters pressure reactor. And then we are adding this activated spodumene sample together with water. We are increasing the temperature and the pressure using a solid liquid ratio of 80 for 3 hours, and then we are able to recover 75% of lithium. That is why I said before that we are in the last phase of optimization. We are trying to increase this percentage in pilot plan in order to 80-85, in order to get the threshold requirement from the battery side regulation that they are claiming that we must recover 80% of lithium. So we are on the way. Once this is already done, then we have to cool down through night, obviously. And then we are proceeding with the filtration. We have 2-step filtration. First, we have a chamber filter press in order to separate the residue. And then we have a fine filtration in order to avoid the blocking of the membrane in the reverse osmosis. Once we have done this, we could proceed with the electrodialysis, but we have some challenges. We have silicon there, and then we got some problems in our membrane, and we need to switch technology. That is why we replace this electrodialysis technology for reverse osmosis. I want to point out here that we also had the challenge to monovalent and monovalent membrane. This doesn't mean that doesn't exist. We know that exists these monovalent membranes, but unfortunately, regarding some, I would say, exclusivity partnerships from the producer of this membrane to other companies, they were not able to provide us this monovalent and monovalent membrane. That is what we have to go through reverse osmosis in order to concentrate lithium in the retentate, and then that we were able to proceed with the crystallization. It's not a problem for us to add a sodium carbonate because we can consider the solubility of sodium carbonate and lithium carbonate, and that is why we are able to get lithium carbonate in battery grade, so purity more than 99.5%. Now the question is, okay, Sandra, great, you are able to get lithium carbonate in battery grade, but lithium is 3% of the input material. What we are going to do with the rest? So that is why we are going through this concept of geopolymer production. Is inorganic and calcium-free polymers based on silicon and aluminum oxide. So the properties are really similar to the cement industry, but a little bit better because the advantage that this material has is 100% built of secondary raw materials. And that means that we are saving of up to 80% of climate damaging CO2 emissions. So you can see the down the carbon footprint compared to Portland cement, then geopolymers using metakaolin, and at the end, geopolymer secondary raw materials. So it's really lower. This geopolymer production is also patented. So it's already, the validation is there. It's not something that we think that could work. Is already patented, so it's working, these geopolymers. Then what we did is a characterization of this lithium-free residue, and looked really promising because silicon is there, aluminum is there, so interesting components for geopolymers. Then we, with a collaboration of another industry, so we are not talking about lab scale, we are going to already validation scale. they already do some treatments, crushing, sieving first, then functionalizing then the material with alkaline activation, and then homogenization, shaping, polymerization, and then making the molded body, and then the testing, so compression testing. Unfortunately, I would say that this was not possible to do geopolymers due to the not so the naphthalene phase, that is kind of death material, and we couldn't work with that. But it's a big but. Despite the limitation, the residues are still suitable for fillers as in the geopolymers building materials, as well as cement industry. And the cement industry, we had another collaboration with another industry, that is Cementos La Cruz, and they were doing validation of this material, and has high reactivity index and high heat release compared to other materials that they are working, like for instance fly ashes. So it's really comparable. So that means that could be possible to work with this in cement industry. So the outlook, I'm finishing this speech with really clear notes. So for us, make no sense to work only from technology point of view or one step of the value chain. We are trying to produce the complete value chain in order to make the sustainable metal supply chain production with innovative processing technologies. Obviously, for that, we need to develop technologies capable of fulfilling the market requirements, so holistic approaches, and we need to increase the processing intensification using modular implementation, that is scalable industrial development, so on site from our client, and integration into existing flow sheets instead of starting everything from the scratch. And for that, we need obviously the collaboration between all the stakeholders, so from industry side, technology providers, research institutions, in order to accelerate the commercialization and the market readiness. So that means that the transition through our sustainably critical raw materials production is not only an environmental necessity, but also a strategic industrial opportunity. So thank you so much for your attention, and I will be glad to answer any question.
Thank you, Sandra. That's really great presentation. That's some really very interesting work that you guys have done. Most certainly addressing the entire value chain. I think that is definitely would make a big difference for industry. It's really critical to address the entire value chain rather than just focusing on one element or the other. My questions, I've got a list of questions actually, but I'll just start with this. You mentioned that geopolymer didn't work. Alternatively, you can use it as supplementary cementitious material. Is that or just as a filler?
Yes, can be both. So we are trying to open the application of this waste material, and first only from geopolymers. It was not possible due to the naphthalene phase, but can be done, can be used as a filler from the geopolymers that was already validated, and as well as from the cement industry. So you can select which application you want to use depending of the necessities from the industry. Like I already provide, we are working directly with 2 different industries, so that means that they are testing that in their own facilities from the production that they are doing daily. So it's something that they could integrate in the currently value chains that they have.
Thank you, Sandra.
Yeah.
I've got a couple of questions on collaboration in general. So how can West Australian companies engage with the Ideas to Industry Lab, which is the joint lab partnership between Edith Cowan University and Fraunhofer IKTS?
Yeah. This is our daily base of this collaboration, and now we have the great opportunity here due to the already established first collaboration with the SAU. So that means that we are starting through the so Australian companies as Australia clients can get in contact with the ECU already. To Steve, I think Steve Elias is already here, or I hope so, and then we can talk together with Fraunhofer IKTS, and we already could do different kind of collaboration. So we can start from technology, or we can already do something together, meaning that we can that the client can tell us what is the challenge, which process they have, and which step of the process, of all the process, should be adapted, and then we can provide different solutions. So the collaboration and jointly cooperation projects can be started from first talks through the SAU, and then the ECU can be the best partner for getting contact to Fraunhofer IKTS. So it's opening the door.
Sure. That's great to know. I've got another question from Curtin University, Diego. What is the minimum lithium percent that is feasible for recovery, and can existing refineries be retrofitted?
Yeah, the minimum, there is no universal threshold. I would say this is depending the regulations that each country has. For instance, in the case of Europe, is a must that in 2031 we must recover at least the 80% of lithium. So that means the 80% of lithium from batteries. So the technologies that we must develop should recover more than this 80%, because like all of you already know, through the complete value chain, you have losses. So that means that at the end of the value chain, the lithium, so all the recovery lithium percentage through all the steps and all the technologies, at the end should sum up with 80% of recovery. So this is our main challenge. So I would say from Europe side is at least 80% of recovery. Then the second question is can existing refineries be retrofitted? I think, and the answer is yes. In fact, in the slide that I show the cool process, we are trying to, for instance, if the rest of the 20% that we are not able to recover, what we are doing with that, we are trying to reuse and as an input material. So that means that this is a closed loop within the process. And this is not ideal or a theory. We already test that and it's working. So that means that we shouldn't think about circular economy, not only circular economy from other companies and other applications, but also within the same process. Because at the end, in the use case that I already showed, if I'm using water, why not using water with some not leachable lithium? Because at the end, I will process the same lithium. So why not closing this loop? So the answer is absolutely yes.
Great. Thank you, Sandra. I've got a question here from Open Chat from David Hicks. You mentioned the lithium from spodumene case is validated at TRL5 with integrated residue management. With the remaining time of 9 months for the project, do you see a TRL of 8 to 9? Not what do you see is the binding constraint that keeps it from going further? Reagent cost, water balance, or impurity creep and the residue stream at scale?
Okay, the answer is from TRL 8-9. No, it's impossible to go through this. The TRL that we will reach at the end of this 9 months will be TRL 7. So instead of 230 liters, we are going through, I think, between 500 and 600 liter reactor. And this pilot plant will be placed in Zetaqua facility. It's a research center here in Barcelona. And the idea that we want to place is the last step of validation of this process, including all the value chain, so the recirculation of water as well. From this main constraint to reach TRL 8 and 9 is that we need to do everything step by step. So make no sense that from 230 liters or TRL 5, we are going directly to TRL 8, 9, especially because the main focus, I would say, is the lithium recovery, and this is only the 3% of the material. So if we are not able to provide and to validate in large scale the residue, the residue stream won't be economically viable. This is a fact. So that means that we need to tackle step by step the TRLs and the scale up, not doing from lab scale directly to the 8, 9 or TRL 5 to the 8, 9. So we will need more time, and we are already talking about this, and we are considering making some extensions or collaborating with some clients that they are already interested. And until this process is not validated in TRL 7, that this will be able at the end of the project, obviously they want to see how it's going on and then proceed with them separately with jointly collaboration until TRL 8, 9.
Yeah, thank you, Sandra. I've got a question from Richard Berger from Chem Center here in WA. So the question is on DBS with high gypsum levels. Is separation and recovery economically feasible?
I would say depending on the input material and depending on the technologies or the pilots that you have. With my experience and the experience that we have in different projects, not only in this Metallico, I would say that recovery could be feasible. The separation is the challenging one, especially with gypsum levels. We already know that. And the main challenge here, I would say, is the compromise between sustainability and economics. Obviously, we want to provide sustainability and not working with, I would straightforward say, with acids and something that can be corrosive and so on. But at the end, if this is already established in the industry, it's really difficult to provide a option or another alternative that can tackle or reach the same success, but improving sustainability. So I would say, I don't want to be pessimistic. I want to be the optimistic one, but I want to be also clear, realistic. Here, there are a huge potential to improvement.
Thank you, Sandra. Probably the last question. I really apologize. I've got so many, a lot of questions, but we don't have enough time. So the last question from Yasamin Hamidian from ECU. What are the most promising technologies for economically recovering lithium and other critical minerals from mine tailings? And what are the key barriers to their commercial scale implementation?
From technology point of view, there are plenty of technology that can be used. This is clearly. From our experience, the main focus back in the days was mainly in the metal separation of the metal recovery. But now, implementing this digitalization and this sensoring from the beginning, so the pre-stages, this is giving us and doing our work easier, because if already from the beginning they already making some kind of smart sorting from hydrometallurgical side, we are getting better material meaning concentrated material, and that means that the success and the and the possibility that this technology is economic is higher. So I would say that now the key, especially with the input materials that we have, especially from primary sources, that the low content of metals, I would put the focus in the first preliminary stages in order to make easier the downstream, so hydrometallurgical recovery metals processing.
Yeah, right, Sandra. I think I can squeeze in one more question from Murdoch University. Is it possible for this research to be used as a base and applied to other minerals?
Yes, from the use case that I already show, we already tested with 4 different minerals with lithium, but I think that the question is more related to other metals. And I would say yes, but not from minerals. We test this, or we are testing. We are now in the first stages of the research with secondary sources from rare earths. So we are checking if not only lithium, but also, for instance, scandium can be recovered using this CO2 leaching approach. And I would say that without optimization, we got around between 60-65% of recovery, and this is great considering the first shot. So we already did the same that we did with lithium, and we are reaching 60% of recovery. So that means that there are a potential of improvement, and we could think about implementing this technology in another metals.
Great. Thank you, Sandra. That's really great. That's been an amazing presentation. Really, we learned so much and about what you've been able to achieve, and the way you addressed the value chain and the circular economy aspects that you included, and the solutions that you included in your process. It's been really worthwhile for all of us. I would like to thank you all as well for attending this, our first webinar. The second webinar is going to be on the 16th of July at the same time, 3 o'clock Earth time. And it's going to be presented by Stephanie Ritchie from CEA, France. In terms of, I know that there are quite a few more questions, so please, you can either send Sandra the questions directly, or you can send it to me, and I'll forward it to Sandra. For any inquiries on collaboration, please direct your inquiries to Steve Elias at ECU, or to Sandra as well.
Exactly.
Thank you all. Thank you all, and have a good day.
Thank you all. Bye bye. Ciao.
Yeah.